You know, if you're additively manufacturing parts, there's an issue, and that issue is you can build it, but once you build it, is it going to work? Now, post-build testing, of course, often reveals flaws. They could be due to residual stress, they could be due to design error. But in every case, there's really no way to know what happened until you've tested it and broken it. Then often it's an iterative process to redesign, build, and test again. But what if you could gather real-time data and actually analyze what happened during the build as a troubleshooting aid? I'm with Graham Boyd. He's Regional Manager for SLM Solutions North America. Graham, we're standing in front of an SLM 125 machine from SLM Solutions. And I understand that you're gathering that vast amount of data I was talking about that lets you kind of know what you're doing while you're doing it.
Yeah, we're really excited. We have introduced a couple new technologies at SLM, our laser power monitoring as well as melt pool monitoring, to help folks with quality part verification. These are capturing with respect to the laser power monitoring real-time capture of the laser power energy as it comes off the laser through a beam splitter, as well as then in our melt pool monitoring the actual thermal emission when the laser power hits the powder bed.
Okay, it's interesting. So you're actually sampling the laser light directly,
That's
as well
correct.
as just measuring the reflected
Correct.
energy.
We're taking a beam splitter and we're actually taking a refraction of the laser power as well as the thermal emission from the melt pool in each respective product.
One of the advantages of laser sintering based metal additive manufacturing, of course, you can make wildly exotic and complex structures. You make structures that you couldn't even dream
That's
of
correct.
doing subtractively.
Sure.
The disadvantage, of course, is that means you can make complex structures, which means it's harder to analyze where the stresses are, either residual
Absolutely.
stresses or functional stresses at that point. So tell me, if you can see it while you build it, does that help you troubleshoot if you mess it up?
It certainly does. So especially as you get into more and more different powders and some of the reactive powders like aluminum and titanium, being able to understand the thermal energies that are going on within the build become really important, especially post-build. Sometimes you might find certain surface roughness and porosity that is obviously an issue in part quality. And this gives folks a reference point to actually understand maybe what is happening critically inside the system to improve upon that or to create successful builds.
Now, enough equipment like this is in the field now. There's user experience space out there now.
Sure.
And what I'm hearing is that many users say that, well, aluminum runs differently.
Right.
And that titanium runs differently.
Completely.
And there's a sense there that they often have in-house people that just have a knack that they get better product running titanium because Bob is the guy who does that.
Sure, sure.
Where's that experience base coming from? In fact, do the powders run differently? And is that something you can see with this data collection?
They do. So for those that are unfamiliar with metal additive, there's parameters that go along with running these different materials. And in that's really where you can kick the training wheels off. And really, as it relates to taking apart to production or even in certain prototyping applications where you really want to do different things with the parameter set to really achieve certain surface roughness or achieve some type of part quality. And in that's where folks are really trying to do creative things, and that's where also inherent issues and pitfalls lie. Where having these type of tools can allow them, while they're working through that iterative process, to be able to identify where those problems exist and how to fix them.
Could this be considered a training aid? Is something you could use to actually bring people up to speed on how to design and run SLM parts?
It is. I actually haven't thought of that myself, but yeah, you could, especially as it relates like the laser output. It would give folks again real-time insight into what's going on with the actual laser to understand if you are seeing any deviations in the thermal energy that's actually hitting the powder bed, where that would obviously create a part issue.
Real-time data collection of the build while it's happening to let you troubleshoot problems. This is Graham Boyd from SLM Solutions.